Let us look at an example for root cause diagnosis of plant-wide oscillations. This example concerns a chemicals plant shown in this layout. The indicator data has been already loaded into a session and the calculations are run. So, let us directly load the session and open the plant-wide oscillations window. We will first go to the Power Spectra tab and add all the indicator variables to the plot. The reason is to identify the tags that have a common oscillation around 300 microhertz, as this is the frequency of interest. Zooming in on the peaks, we find prominent peaks at 3 frequencies. Since we are interested in the disturbances around 300 microhertz, we zoom in on that region. We identify the variables that have significant contribution to that frequency. We end up with the variables PV5, PV7, PV8, PV12, PV13, PV19, PV22, PV23, and PV25 that have significant contributions. Next, we go to the Correlation Analysis tab to figure out the correlations between these variables, especially the lags, in order to perform the root cause analysis of the oscillations. The Select Loop option here helps in isolating particular loop variables for facilitating tag selection. In our case, we only have indicator variables, and therefore, we can skip this. Variables or tags can be selected in both these drop-downs for performing correlation analysis. There are also options to select all variables or a set of specified variables. We will use the Specify Variables option in both these drop-downs to specify a set of variables to get their correlation and lags heat maps. Let us now specify the variables previously identified and hit the Execute button to get the results. Although correlation heat map is useful for evaluating the correlations between the variables, our focus at present will be the lags heat map. Instructions for interpreting the heat maps are given here in this analysis text section. If an element in the heat map is green, then the corresponding row variable leads the column variable. If it is red, the row variable lags the column variable. We will look for the row having the most green elements. We can identify PV22 and PV23 as the variables with most green elements. Among these two variables, we can understand that PV22 leads PV23 by looking at this corresponding cell. We can also plot the cross-correlation plot between these tags for confirmation. To do this, we choose these two variables in the drop-down menus and hit Execute. As confirmed by this plot and the analysis text provided, PV22 leads PV23. We can also check the correlation of PV22 with the other specified variables by choosing PV22 in one drop-down and Specify Variables option in the second. Clicking the Execute button results in this chart. In this chart, the trend in blue represents the correlation coefficient and the bars represent the lags. From the analysis text, we can understand that negative lag means the particular variable lags PV22 and a positive lag means that the particular variable leads PV22. We can see that all variables except PV12 and PV13 lag PV22. To find what is going on with the variables, PV12 and PV13, let us look at a comparison of their trends relative to PV22. For doing this, let us go to the Trend Comparison tab. Let's add PV22, PV12, and PV13 to the plot. We can see that PV12 and PV13 are exactly out of phase with PV22, making it difficult to predict the lags. Since the available data does not contain the origin of the oscillations, it is impossible to ascertain the real causality between these variables. However, the knowledge of the plant layout helps us in correctly identifying the source of the oscillations to be PV22. The Correlation Analysis tab also has other useful features, one of which is the autocorrelation plot. Selecting the same variable in both drop-downs will create an autocorrelation plot. Another feature is the ability to select time windows for each of the variable. This is useful for using specific time windows in the variables for correlation analysis. This feature is accessed through this yellow button. After selecting the windows through the sliders, click the Accept button to accept the changes. Now, clicking the Execute button will result in the specified data window being used for the correlation calculations.